Hello, hello, hello. Hola, 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 hola. Cuando? Can you hear my voice, guys? Loud and clear? Hello?
Hi, Mr. Bluetooth.
Yes, Mr.
Hello. Okay, guys, good morning. Today we're going to continue with the practice part where we're talking about the congruency of triangles. Remember, the congruency of triangles is given by triple S, SAS, AAS, and ASS, okay? So, in this situation, we have to try to find out the congruency. For example, in the first one, the problem says the vertices of the triangle DCA are C equals -5 with 7, D -8 with 6, E -3 with 3. And the vertices of the triangle FGH are 5, 7, 8, 6, and H3, 3. So we have two questions, one or two requirements, actually. The first one, we have to verify if those triangles are congruent. Okay, that was the first requirement. And the second requirement is name the congruency transformation from the triangle CDE F FGH. I mean, what will be the postulate of the congruency in this situation? Okay, what we have to do? Well, actually, every time that we're talking about the vertices giving information, the first thing that we have to do is graph the vertices of those triangles using the coordinate plane. This is going to be the first thing that we must to do in this kind of problems. Okay, just trying to verify if we have the right measures of the triangles to the left and right side. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 units. 1, 2, 3, 4, 5, 6, 7, 8 units. And 1, 2, 3, 4, 5, 6, 7, 8 units. And 1, 2, 3, 4, 5. Let me move a little bit downward this one. 1, 2, 3, 4, 5, 6, 7, 8 units. Okay, and we are create the coordinate plane. What we have to do? Well, let's going to label the vertices at the beginning. For example, the letter C, we have -5 with 7. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, this is going to be the vertex C. -5 with 7. The another one, -8 with 6. Okay, 1, 2, 3, 4, 4, 5, 6, 7, 8 with 6. Okay, 1, 2, 3, 4, 5, 6. This is going to be the vertex D. -8 with +6. And finally, -3 with 3. -3, 1, 2, 3. And this is going to be the vertex E. This is what we call -3 with 3. Okay, and let's going to sketch the triangles. All right, just we have to connect the 3 points and we draw the first triangle. What kind of triangle over here? We don't know yet. It could be right triangle, equilateral. It could be scalene, could be isosceles. Okay, but the most important thing, we are creating the first triangle. All right. Now we have to sketch the graph using the other 3 points. For example, the first one, 5 with 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. This is the vertex F. 5 with 7. The another one, 8 with 6. 3, 6, 7, 8. 1, 2, 3, 4, 5, 6. Vertex D. 8 with 6. And finally, 3 with 3. 1, 2, 3, 1, 2, 3. Okay, this is going to be the vertex edge. Okay, given by 3 comma 3 units. Okay, and we can perfectly sketch the second triangle, right? Connecting the 3 points. Okay, the first one with this one. Okay, this con this one. And finally, H with D. Okay, and we got the two, we have the transformation, the two triangles. Or if you see, we have the selection of these two triangles in this case. Now, how we can make sure if those triangles are congruency or not? Simple. We have to try to find out what will be the measures of their distance. I mean, in both sides. This is not complicated, not big deal, but we have a lot of work because we have to find out the distance between FD, DH, FH, the three sides of this triangle, and the three sides in another triangle. Well, because we don't need the rest of the coordinate plane and we really want to improve or actually take the space of this whiteboard, I'm going to erase the coordinate plane, right? Just to differentiate or just for obtain space, just like, for example, to create the equation. So actually trying to find out what will be the measures of the sides of these triangles. And if you wish, or if you want, we can paint every triangle if you wish, right? It's just like a optional step just for differentiates one triangle to another one, right? We have the first one, this is the second one, and we can paint it. Okay, now what's going to do? It's going to try to find out what will be the distance between in the first one, what will be the distance between DC, all right? DC. Remember, the formula from distance is given by x2 minus x1 second power plus y2 minus y1 second power. Well, actually the square root covers the rest of the equation, okay? Now, DC will be equal to square root. X2 will be -8 minus negative times negative is positive, positive 5 second power plus, in this case, will be 6 minus 7. 6 minus 7 second power. So distance DC will be given by square root of what? -8 plus 5, -3, -3 second power, positive 9, plus 6 minus 7, -1 second power, positive 1. So we can conclude the measure between D and C will be 10 units, square root 10 units. We have the first distance, DC. The second one, we can calculate the distance between, this case will be DE. Applying the same formula, okay? We can say -8 plus 3, because negative is negative is positive, positive 3 second power, and plus 6 minus 3 second power. Okay, for that reason, distance DE will be -8 plus 3 is -5. Second power will be 25 plus 6 minus 3 is 9. 6 minus 3 is 3. Second power, 9. And distance DE will be given by the square root of 34. And finally, we can calculate DC, DE. Now we can calculate the distance CE using the same formula. CE, you know, -5, -5, negative positive 3 at the second power, and plus 7 minus 3. Okay, so if C, DC distance will be given by -5 plus 3 is -2. Second power, 4 plus 7 minus 3, obviously will be 4. Uh, 4 second power will be 16. Okay, and you know 4 plus 16 will be square root of 20. And 20 can be simplified like square root 4 times 5. You know, 4 square root 4, that will be 2. So distance CE will be 2 square root 5 units. Okay, and we got the measure of this triangle. Okay, you know, remember, measure between D and E, square root 34. Okay, the measure between C and E will be 2 square root 5. And obviously this one will be square root of 10. This is going to be the measures of the first triangle. Now what we're going to do with the second one, we're going to repeat the process once again, but this time we start using obviously the another vertices. I mean, we're going to try to find out, if you wish, distance between FD, FH, and DH. Actually, the three, it doesn't matter the order. The result that's supposed to be the same, right? So distance FD, remember, square root of 5 minus 8, second power, plus 7 minus 6, second power. Okay, FD, you know, 5 minus 8, we have 9 units because 5 minus 8 is -3. -3 second power, 9, plus 7 minus 6, that will be 1. 1 second power, 1. So we can conclude this is going to be square root of 10. Okay, the first measure located over here will be square root of 10. Okay, now repeat the process. We can try to find out distance between FH, this side. Okay, repeat the situation. 5 minus 3, second power, plus 7 minus 3 at the second power. So in this case will be 5 minus 3 is 2. 2 second power, 4, plus 7 minus 3 is 4. Second power, 16. So this is going to be square root of 20. And at the same time over here will be 2 square root of 5. So 2 square root of 5. Okay. And finally, the distance DH. Distance DH will be given by A minus 3, second power, plus 6 minus 3, second power. Distance DH will be given by A minus 3 is 5. 5 second power will be 25. 6 minus 3 is 3. 3 second power will be 9. And this is going to be square root of 34. So if you see, it's square root of 34. Okay, so we can manage what will be the postulate of congruence, right? So the postulate of congruence is what we can say. We can say, for example, the distance, the distance DC will be congruent with which one? With FD. DE congruent with one will be with DH, right? No, no, déjeme ver. FG, este es 8,6 la G, no D. Este es G, perdón. Esta es la letra G. Y entonces este es GFG. Disculpen la letrita. Este es G. Este es G. 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 Y este es GH, no DH. Este es GH. Perdonen, muchachos, ahí el errorcito. GH, GH. Well, DE congruent with GH. GH. And finally, CE congruent with FH. So because the three sides are congruent, okay, so in the first question is verify those triangles are congruent. Yes, we are verified already. So triangle CDE congruent with triangle FJH. So name the congruency transformation of this triangle. The three sides are congruent. So they're congruent by S, S, S. Triple S because the three sides are equal. Questions or everything is clear? Hola, ¿todo claro, todo azul?
Mr. In the final answer of the distance, we no, but like in the that you leave it with the square roots.
Yeah, we can leave in this the square root 34.
Oh, okay.
And that's it. You don't need to use decimal numbers. Yeah, you don't need to solve it. But if you wish, there is no consequence for that situation. But just in case, if the square root has a whole number, for example, if I said square root of 81, okay, in that situation, yeah, square root of 81 will be 9. If I said square root of, for example, 64, 8, just in case we have whole numbers. Okay, let's going to analyze the second problem. In the second problem, my dear students mentioned, use the following information. Triangle QRS is congruent with the triangle JHJ, no, GHJ, and gave us some kind of measures. What measure the problem gave us already? Gave us RS, that's supposed to be 12. And after that, QR gave us 10. And the last one gave us 6. Okay, so according for, and finally, the problem mentioned and gave us HJ, right? So the problem says, okay, we have draw a label figure to show the congruent triangles. Okay. Using the coordinate plane for doing this example, now we cannot use in the coordinate plane because never gave us the coordinates, right? They only gave us the answer from the for the distance of the measure their side. So we can draw the points whatever as you want. For example, I'm going to take in the first example, I have RS, QR, and QS. This is going to be enough to draw the triangle QRS, okay? I'm going to label the points. Point Q could be over here, right? Could be Q, could be R if we wish, QRS. Or if you wish, we can use the distance between RS and Q. It doesn't matter the order. But remember, a triangle, obviously, we have always, without exception, three sides. Okay, that's This is a easy way how we can identify these situations, okay? So we have the connecting point QS, RS, and QR, and we can form this triangle. And let's going to see what will be the measures. The measure, the first one, according from the problem says, RS that's supposed to move, it has a measure of 12 units. 12 units. And QR, 10 units. Okay, and finally QS 6 units. Oh, if you see, we have a triangle, but not necessarily with the right measures, right? So what does that mean? I have to, if I want to draw this triangle, I'm going to separate the distance according to their measures. Okay, what I'm going to say, I'm going to fix this one. Okay, remember R with S, we're supposed to have a distance of 12 units. RS, 12 units. Let me fix this one. RS, 12 units. Okay, that will be better. 12 units. And QR, 10 units. So we can connect the point QR in 10 units. And make more sense, right? Because the highest value will be 12, the second one will be 10, and the third one obviously will be 6, the shorter value in this situation. But if you're not convinced with the letter S, I'm going to approach this over here. Don't like it at all. Sea más cortito. Como este número 6 es el más cortito, entonces lo ponemos así. Este es un poquito más largo, que tiene que verse la diferencia. En que si este es el más cortito, tiene que ser el más corto. Entonces este es el más largo. Y este es el segundo que va. No. Más o menos algo así. Por ahí se va. Déjenme ver, no necesariamente este tiene que ser un poquito menos. Tendría que ser algo así. Por ahí. Algo así. 12 and 10 units. And this is going to be the QS and QRS. Okay. QRS. Now we have to label the another triangle. Remember that those triangles that's supposed to be congruent, okay? So the letters that we're supposed to have, the triangle GHJ. So we have to label in the same position with the first one. I mean, I'm using in this line QS, right? The first letter and the third letter. So I'm going to use in the second triangle, the first letter, G, and the third one will be J. Okay, and the last one, J, and the middle one will be H. Okay, and I'm going to connect the two triangles. I mean, we have connect this position, this one, this one, this one, this one, and this one, this one. Okay, then. And remember, both triangles, that's supposed to be congruent. But if you see, the problem says, okay, HJ has a value of 2x minus 4. Okay, and remember, the rest of the triangle, that's supposed to be congruent because at the beginning of the problem says the measure, this triangle is congruent with this one. For that reason, QX measures 6 units. This was supposed to be measured 6 units. And QR measures 10 units. So this one, that's supposed to mean 10 units, right? And we have obviously the label, the problem, all right? We have to find out Obviously, the problem mentioned both triangles are congruent. And we have the, how to say that, the label, the picture of the congruent triangles. Now what we have to do in the second part says find X. Well, it's the easy part in the situation. So trying to find X, the only thing that you have to do is identify what will be the congruent side with JH. And obviously, according to the picture of the triangle, the side RS or the leg RS that will be congruent with the leg HJ, right? So RS will be 12 units. By the other hand, we have 2x minus 4. For that reason, 4 is subtracting, passes to adding. 12 plus 4 equals 2x. This is going to be 16 equals 2x. For that reason, 8 equals the letter X. And we have the solution set for this problem. That was the letter A, and this is going to be the letter B. Questions? Ouch. Preguntas, muchachos. ¿Todo claro, todo azul? ¿O no?
Todo claro, miss.
Sí. El detalle es, si usted me pregunta cómo supe dónde iban las posiciones de Q, S y R, usted podía haberlos colocado donde quisiera, ¿verdad? Pero las medidas me va a decir quién es el más grande, quién es el mediano, quién es el más pequeño. Y cómo suple que G, J y GH medían 6 y 10. Muy sencillo, porque el problema me está diciendo que esos dos triángulos son congruentes. Entonces solo me tengo que fijar en la posición en que yo dibujé los vértices del primero con la posición de los vértices del segundo. Yo utilicé en el primero, en la parte de arriba, la primera letra con la tercera y como vértice central puse el de en medio. Ah, bueno, como yo lo tomé así en el primer triángulo, para no hacerme bolas, hago lo mismo con el segundo. Tomo la primera letra con la tercera como horizontales y cogí como vértice la del medio. Y simplemente etiqueté los lados según lo que me decía el problema. ¿Ok? Entonces, vamos a tomarle un print screen a esto y se lo vamos a mandar por el grupo de WhatsApp. Déjeme buscar. Ay, 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 ay. Aquí está Geometry and Physics. Mejor jugador de Panamá. Ustedes, muchachos, creen en la selección y no creen en San Nicolás. Deberían de creer en Papá Noel. Yo creo que es más fácil que les traigan regalos a que la selección gane un partido. Pero en fin, hay que respetar, ¿verdad? Las opiniones de, de lo que creen y lo que no creen las personas. Pero en fin. Okay, let me know when you're finished to copy that whiteboard. All right. And let's perform another example.
Mister, en la distance de FG, en el primer problema, como la fórmula dice x2 minus x1, no sería como 8 minus 5.
Podría ser, no importa. Mira, usted pudo haber comenzado como el primer punto 2, el segundo punto 1 o al revés. Al final, la respuesta le va a quedar, perdón, exactamente lo mismo, solo que tiene que cuidar los signos. Eso sí, o sea, si usted lo pone al revés, yo le aseguro que le va a dar lo mismo, solo que tenga cuidado al momento de manipular los signos. ¿Ok?
Ok,
Ya lo
gracias.
mismo, a la orden. Entonces, en el primer problema, utilizamos el plano cartesiano para ubicar las transformaciones. Entonces, ya una vez hecho, lo correcto hubiese sido dejar el plano, pero como no tenía más espacio en la pizarra, Por esa razón fue que se borró el plano cartesiano, dejando los vértices para que quedara la figurita de de perdón, de los triangulitos y poder pues efectuar la formulita de la distancia. Yo creo que hay un tercer espacio, creo que se mira bien esquinita, no necesitamos borrar la pizarra. Ok, vamos a ver, me dicen si se puede leer donde voy a colocar el problema número 3. Ok, the problem number 3 says find x. ¿Se lee esa parte? Dice find x. ¿Sí o no?
Sí.
Okay, perfect. Let me draw the picture of this problem. All right. Sorry. And we have the measures. Be careful with the measures, guys. Listen. 60 degrees. Okay. 60 degrees. Body on the hand. And it says 3x minus 13 minus 13 over here. And another one is 2x plus 5. Okay, can you see that triangle? Can you see that one? The problem number 3?
Yes, Mr.
All right then. So in the problem number 3, obviously we had to try to find out what will be the value from x. Okay, by one side and by one hand. And you see we have two kind of triangles. I don't know if you identify what kind of triangles do we have in that picture. If you see, the first triangle in the located in the vertical position is a equilateral triangle or equiangular triangle. How do I know that? Because if you see the angle of the base that's supposed to be congruent and the vertex has a value of 60 degrees. What does that mean? That means that three sides of the first triangle that will be congruent. So my strong recommendation every time that we have this kind of problems, if you wish, we can separate this triangle into parts. In the first one, okay, you're going to see over here, okay, and what the problem says. We can label the vertex if we wish. We can label like A, B, C, A, B, C, and D, if you wish, okay? And the equilateral triangle, because the three sides will be congruent. And the three angles has a value of 60 degrees, 60 degrees, and 60 degrees. Because vertex 60, 60, 60, for that reason, every side has a measure of 2x plus 5. Okay, the three sides of this triangle that's supposed to meet the measure. How about with another one? In another one, we have an isosceles triangle. How do I know this is going to be an isosceles triangle? Because if you take a look, the angle of the base, that will be congruent. For that reason, the angle of the vertex will be different. So in this situation, we have the vertex B, D, and C. The problem gave us the measure already. What is the distance between CD? The distance between CD will be 3x minus 13. Okay, and the distance between BC, if you see three sides that will be congruent, this is going to be 2x plus 5. And because we're talking about isosceles triangle, remember the sides for this isosceles triangle, the legs, that will be congruent. according from the postulate. For that reason, what I'm going to do, simple, we're going to apply the postulate. In this situation, the measure the segment of the line BC that will be congruent with the segment on the line DC. What is the value from BC? BC is 2x plus 5. Value from DC, 3x minus 13. Well, we can regroup, all right. So 2x minus 3x equals negative 13, negative 5. This is going to be negative x equals negative 18. For that reason, x equals positive 18. And that's it. That's all that we have to do in the problem number 3. Ouch. Questions or everything is clear?
Mister, can you explain example number 3 again, please?
Okay. If you see, we can split the triangle in 2 parts, okay? The first one and label the vertex A, B, and C. If you take a look, the angle of the vertex, I mean the superior part of that triangle is 60 degrees. What does that mean? Vertex 60 degrees and the angle of the bases are congruent. That means the triangles that has a value of 60 degrees. And this is what we call a triangular triangle or equilateral triangle because the 3 inside angles will be the same and the legs will be the same. I mean the distance between AC, BC, and AB will be 2x plus 5. Okay, but on one hand. And if you check the other hand, in the other hand, the triangle formed by the vertex D, B, and C, we have the angle of the base, all right? Both are congruent, but we don't know what is the value of the angle. Now, according for the picture, both are congruent because we have 2 lines remarkable in the angle. And the postulate says, isosceles triangle, the angle of the bases will be congruent and the lateral legs will be congruent. For that reason, according for the postulate, the length CD that will be congruent with the length CB. Okay, that's why I'm using the isosceles postulate. BC equals or congruent with DC and using both equations, solve for X, and that's it. Got it? Got it?
Yes, Mister. Thank you.
Oh, okay, my pleasure. Okay, guys, I'm going to take a print screen and I'm going to send you the WhatsApp group. Oh, yeah, the WhatsApp group. And that's it because we are out of time. We're going to continue solving a few problems the next class. Okay. Thank you so much for your attendance. Have a great and wonderful day. And yeah, Jorge, tell me.
Mister, how do you know that BC is congruent to DC?
Porque es un triángulo isósceles. Fíjese bien. ¿Ve usted los 2 ángulos que están en la base? Donde está la B y la D. Tiene 2 vueltitas cada uno, ¿cierto? Eso quiere decir que si los ángulos de la base son igualitos, significa que los laterales también van a ser iguales. Es lo que dice el postulado de los triángulos isósceles. Y en el triángulo de la izquierda, ¿cómo supe que los 3 medían lo mismo? Si usted fija, A y B son igualitos, ¿verdad? Pues tienen una vuelta. Pero me está diciendo que el vértice mide 60 grados. ¿Qué quiere decir entonces? Que los 3 lados, los triángulos tienen que ser igualitos. Y si los 3 ángulos son igualitos, los 3 lados de cajón tienen que ser igual. Es decir, que AC, BC y AB mide 2x más 5. Y como el lado BC está compartiendo los 2 triángulos, por eso es que se iguala al triángulo isósceles. Porque el triángulo isósceles dice que si los ángulos de la base son iguales, los laterales también van a ser iguales. Es por eso.
Ok.
Bien, es por eso. A ver, Efraín, dígame.
No, mister, lo mío es que le quería preguntar si podría conocer cuando terminar la clase, cuando se fueron todos. Disculpe.
Ok, no hay problema. Bueno, los demás muchachos, ¿alguna pregunta? ¿Alguna pregunta?
Mister, yo igual necesitaba hablar con usted después de clase.
Ok, perfecto. ¿Alguien más entonces que necesite o si no, el resto de la clase podéis ir en paz?
Adiós.
¿Pero? Ajá. Bueno, ¿quién quiere que quién empiece? Solo tengo 6 minutos antes de comenzar con séptimo, así es que ni modo, permítame, voy a pausar la grabación porque esta no es parte de la